All right, what's up, boys? Oh, that's cool. I can't share. I need to get another monitor. I wonder if I could do that. Yeah. Running out of like display ports on my. There we go. Okay. Just saying, I feel a little bit sick and I have a headache, so I might be slow today. It's okay. Sorry to hear you're not feeling okay, Teacup. That sucks. You guys gotta eat your veggies. You're getting sick from. No getting sick. No time to get sick. To answer your DisplayPort problem, get a USB hub. Oh, you mean like have another display using a... Yeah, see, like, I'm already running 3 monitors. Plus... Wait, 3 monitors... Oh, plus I'm running an output to a capture card. So I think I'm using, like, all 4 of my outputs on my video card. I have a 3070 Ti. I think I'm already using 4. I need, like, 6. What's going on, Rip? Good to see you, bro. Hello, Ethan. Oh, you're gonna... Alright, let's see this. USB-C hub, he says. Does this work as an extra graphics adapter? I think it only works if you're doing it with a laptop, though. Does this work? Let me see. Well, also 80 bucks. Jesus, no. I could just buy another video card for 80 bucks. Actually, I do have another video card. Wait a minute. Ooh. Here, now that's... Ooh, okay, now we're thinking with portals. I have another video card I could probably throw in. I wonder if I have 2 slots, though. For the... What is it? The PCI Express? I have 2 PCI... I probably don't. I think you only have 1 these days. Yeah, these adapters, Teacup, usually only work with laptops. They only work with laptops. I don't think they work with motherboards because the motherboard, the graphics adapter goes through the video card. It's not on the motherboard. What's up, Dark Aspect? Good to see you, brother. It works for a computer? Did it, Teacup? Are you serious? I think if the computer has the graphics card adapter on the motherboard, it does. Yeah. Well, yeah, I wonder about your brother's computer. HDMI port, both a single monitor display. Because here's the I have a what is it? I have a B450 Max Tomahawk B450 Max Tomahawk. This is my motherboard. I need to honestly upgrade this motherboard too. Yes. So, like, what are all these? What are these ports? Here are the ports. It does have an HDMI. I think that only works if the processor I'm running has a built-in video card. I think that's the only way that this works. Someone correct me if I'm wrong. Because yeah, I do see there are a lot of video adapters on this, but I don't think they work. Okay, ooh. And it does have 2 PCI Expresses. I probably could run another one. The question is, does my 3070 Ti block that? Now I'm curious. Ooh, that would be pretty cool. Yeah, there's a lot of stuff. Okay. Maybe I'll try this out later today, cuz yeah, this would be cool to do. Cuz then I could just run like a 4th monitor. Or just a dummy monitor, I think. Like a dummy display or something. Curious. I wonder if that works. Yeah, because I think I have... I gotta remember how many slots the 3070 Ti takes up. It may take up like 3. Alright, cool. Anyways, let's see. Damn, I actually gotta go. Bye. Okay. Bye, Strider. Hope to see you back again soon. Second first time cheater's choice. What's up? What's up, Strider, dude? First time chat. Anyways, yeah, it's Friday. All right. Let's kick off the stream. We got a decent amount of people here. All right. Welcome to Office Hours. My name is Dr. Goldless Actual Education, the stream that helps you out with your math homework, science homework, all sorts of fun stuff. Let's see, how is, I want to see how this is working. Yeah, chat looks okay. I've been actually messing a little bit with the OBS, to try and, like, make sure that it's all, like, correct and whatnot. You might see some things moving around. Yeah, I think this needs to move to the left a little bit. Let's bring it in. There we go. Okay, and then I think I want to move this a little bit up. There we go. Okay, cool. All right, that's fixed. All right. I was just cleaning some stuff up. See ya, Strider, dude. It's Lemons here. What's Lemons here? Oh, your name is
Lemons. Oh, hi, Lemons. No, it's nice baby got the baby voice on. All right, now I'm going to talk like a little kid. That's kind of fun. Okay, cool. All right, let me exit this. We don't need to full screen project this anymore. All right, let's go to our first question today. Also, welcome Ramit into the chat. Some of you guys are wondering, they're like, wait, who is Ramit? I'll make a formal announcement in the Discord once we have everything finalized and maybe Ramit comes up with a cool nickname that he wants to go by.
Yes, I promoted Ramit to TA. I'll make a formal announcement about it in the Discord, but just in general, he was super helpful this last couple sessions with some of the more advanced math questions we've had, especially from you, Noise. So I'm looking forward to having him on more of the streams with us, and maybe his own section, his own little stream, as we move forward with things. Super hyped. I love to have people that help out, and I love people that like share the dream of helping all you kids. Yeah, Noise says, oh yeah, good stuff, yeah. Chaotic Dude is his name in the Twitch. Yeah, that's him. Yeah, cool. All right. Where's your question? Aspect had the first question. We have a lot of questions today. Okay, cool. Coming soon, soundboard. Oh, there's a soundboard thing for, oh wow. Discord really is, here, look, check this shit out. Like, Discord really is trying to, use the soundboard. Wow. Yeah, okay. Discord's really trying to start taking over Twitch. Yeah, Chaotic is a top man. He is. He's dope. Allow members to send sounds from server soundboard. Man, that's cool. Where's the soundboard though? Where are the rules for the soundboard? I'm curious. Yeah. Where's this soundboard thing? Soundboard fact. Experimental feature to play on desktop and limited number of communities for mobile users. What is a soundboard? The soundboard is over here. Kind of looking at this. It looks pretty cool. Always like when they have like Discord's putting out some cool stuff. Oh, sick. Okay. Oh man, this is gonna be chaos, dude. They're allowing people to run their own soundboards within the Discord voice channels. Oh god. That's about to be interesting. Quack, golf clap, sad horn. Okay. Oh, okay. Cool. Oh, and you can change the soundboard volume. Wow. Oh, okay, but in order to use a soundboard, you have to have a Nitro subscription. Oh, that's across servers. Okay, but within the server itself, you don't need Nitro. Very cool. All right. Dope. I always like when they're coming out with new stuff. Pretty cool. All right. Got that. I have my pen. Good. All right, let's go to the first question of the day. I do like his question, right? Yeah, it's a good question. Yeah, here we go. This was the first question of the day comes from Dark Aspect. He's asking, why did the bottle implode after I spilled all of the hot water out? That's kind of cool. So wait, first of all, you had hot water in a plastic bottle? Usually not a good idea. Things called BPAs. You can come up and speak. Where is here? Nick, you want to come up and talk? Come up to the stage, dude. Come up to the stage. Also, ooh, they changed the whole stages layout too. This looks very different. How do I like? I don't want to like. I don't need to see myself.
Yo.
Show my screen share. I don't need to see my. I don't need to see this. There we go. Okay, awesome. It was it was doing some weird stuff there. Okay, cool. What's up, Nick? How's it going, dude?
Good, you?
Good. I'm good. It's Friday, dude. We're I have a calculus problem I'm stuck on. Yes, noise. Post it in screenshots. I love calc more than I love vectors. I'm getting to learn. I'm learning to love vectors. I am learning to love vectors. It's okay. Okay. So Nick, you had a question about like so you had it looks like a Fiji water bottle, like a plastic Fiji water bottle, and you had hot water in this. Why'd you have hot water in it? First off, you shouldn't put hot water in plastic bottles.
Not hot water, like boiling hot. I just put hot water from the sink
Oh, okay, cool.
to
And
rinse it out.
Oh, to rinse it out. Oh, I see. And then it kind of
Yeah.
compressed on itself, is what you're saying?
Mm-hmm. Yeah, when I put it on the cap.
Oh, once you put the cap on. Oh, very cool. Yes, this is a physics question. I love physics. Yes, here we go. Okay, cool. Okay, so yeah, that's the key thing here is. So, exactly. Yeah, he closed the water bottle. Yeah, he had to. Yeah, right, Ramit? Otherwise, it wouldn't make any sense. Yeah. Okay, so this comes down to a very cool thing called, because otherwise I was like, wait, how is it doing that? Yeah, you need, this goes down to what's called
Magic.
the ideal gas law. Which is a physics concept. And basically what it says is there's a relationship between a bunch of different, they call them state variables, but really it's just a fancy word for like characteristics about like a gas or something, okay? And the equation goes like this. PV is equal to nRT. Anyone seen that equation before? Pretty cool one. I'm guessing you haven't seen it before, Nick, right?
Nice.
Awesome, dude. Thank you for the follow. Please no, NKT is the only way. I forget now. No. Isn't it Ramit? Isn't it PV equals? It's capital NKT, right? Isn't that the other one? I feel like one of them is like
it is.
right.
It is, yeah. So
What's the
N-
difference between
small
these
n is
two?
small n is the number of moles, and
You
then
don't like
R
that
is
one?
like the Rayleigh's constant.
Yes. Yeah, this is the gas constant,
Yeah, and then
which is
yeah,
dependent on the
I think
mass.
that's they call it the Rayleigh's constant or something.
Raleigh's
like that.
constant. Yeah. Okay. Cool. All right.
Yeah.
And then
And then
this one is
N
what?
is the number of particles,
Okay.
and then K is the Boltzmann constant.
I see. So K doesn't change, basically. But I think R does change. Does R change based on the gas?
No, they're both the same. But
They're both the
constant.
same. Yeah. This one you have
Yeah,
to multiply.
essentially it's just the
You have to.
same-
This is Avogadro's number, though, right? This is where you need like right? Yeah. You need like the actual number of particles.
Like essentially you multiply the small n by Avogadro's number to get big N,
Mm-hmm.
and then R becomes divided by the same thing.
Ah.
So then,
Okay.
yeah, they're just they're the same thing. It's just whether you use in chemistry, you use moles, and then in physics,
Yes.
you use number of particles.
Exactly, yeah. I've been teaching a lot of chemistry lately. That's why I know this one so much. But you're right. Yeah, it's actually funny we bring that up. This is a cool little side topic here. But yeah, chemistry and physics, right? Both go over thermo. They both thermodynamics and thermochem. That's what this is here, Nick. It's called thermo.
Yeah.
Yeah.
All I understood is that you guys are speaking another language.
We're nerding out. We're nerding out over the ideal gas law. It's kind of fun. I feel like Noise might know this. He's a little bit up there. But in general, there's this weird thing where like physics and chemistry have like joint custody over thermo, and they use different equations and conventions for the same thing. It's like it's really annoying. Ramit, do you know the other one about like E is equal to like Q plus W versus E is equal to Q minus W?
Yeah. I think. Oh, yeah. I forgot which.
I think this one
Q
is chem,
plus
and then
W is the-
I think this one is chemistry. This one's physics. And then
Yeah, I
they
forgot which
define
is
work as I think like negative P dV, and then here they define it as work is equal to P. It's like whether you define work as work done on the system or done like by
Yeah.
the system, right?
Yeah, that's true.
Yeah. So this is another example of like, yeah,
Huh?
it's so Nick, chemistry and physics both cover similar topics. And one of those
Mhm.
topics is called thermodynamics, which has to deal with heat, has to deal with how heat changes and whatnot. And they have equations that they use to describe. This is an equation that describes the change in energy of a system due to the heat and the work. But whether you're in chemistry or whether you're in physics, you'll use a different equation because like they do different things with the pluses and the minuses. It's super confusing.
What is
Well-
the difference between them?
The difference is one of them has a plus, one of them has a minus, and
No, I mean
what?
like between chemistry and physics.
Oh, okay. They're just two different subjects. They're two different disciplines, I guess, two different fields and whatnot. So, it's like I'm trying to think what's an example of this. Where you have like two things and like, oh, we're gonna study the same thing.
Are you talking about like the Q plus W one?
No. I'm just saying in general, like an overarching topic, not like a nitpicky thing. I'm trying to think of like something outside the world of physics and chemistry where you have two disciplines studying the same thing and they come up with like kind of different rules for it.
Oh, true.
Yeah, right. Oh, that's what I'm trying to find another example for that.
I'm trying to think.
What would it be?
Sometimes there's like physics and engineering as well.
Yeah.
Like circuits.
Yeah, that's another good one. Yeah, physics and engineering will both study like electronics and whatnot, but they'll kind of come up with different ways that they do things. But they're studying the same stuff. Yeah. Engineering is notorious for using tables on all their stuff. I think I've shown this to you guys before, where like physics, you have to use all these equations to like figure out like the nitpicky things of like, you know, what's the temperature here, what's the pressure here and whatnot. Whereas engineers will just like make these massive tables where all the calculations have already been done. And you just have to look up like on a table, if my steam is this hot and I'm at this whatever pressure, this is like my, I don't know, my heat capacity or something. Yeah. Rather than calculate it, they just look it up. It's more practical. It's practical because as an engineer, you're doing real world problems. You don't really care about all the underlying math to do it. You're just like, just get me the number. It's cool. That's a more broad topic. Noise says, is specific heat capacity defined different in chemistry as well? I don't think so. I think it's the same. Good
I
question.
think one's like per grams per centimeter or something, and then the other one's like kilogram per meters cubed.
I see.
So-
Okay.
I think different units or something.
Yeah.
But it's just kind of the same.
This also happens even within physics, right? Because we have CGS, SI. CGS stands for, what is it? It's centimeters, grams, seconds, and then SI deals with, I think, meters and kilograms, right?
I think so. Yeah.
Yeah, and then you can, and mostly what? Sorry.
I've mostly seen SI units, but
Yeah, most of things are in SI.
People always use different.
It gets weird also in plasma physics with what I work because sometimes, there's Gaussian units and then there's I forget what the other ones are, but yeah, they start doing some weird stuff. And then if you start getting into like really high end like string theory, whatever, quantum, whatever stuff, don't they start like calling like C equal to 1? They're just like the speed of light equals 1. You're like, what?
Yeah, they like normalize everything by like C.
Yeah.
Like, they just drop all the constants always.
Yeah, they're just like, you're
C,
just like, bye bye.
pi.
Yeah, it's too funny, man. Yeah, it goes deep. I can nerd out forever. Okay, but Nick, to get back to your original question. Okay, ideal gas law. We're gonna use the NRT one because I've just been using it for now. NKT does work as well, but okay. We're gonna go over what all these different variables are. P here. This is the pressure. Okay.
Mhm.
This is the volume. This is called the number of moles, which is a big fancy word for like the amount of gas, basically, of gas particles, kind of. Okay. This is a constant. Constant means you don't need to worry about it. And then T here. This is the temperature. Okay. Noise says, I wish I was better at physics. It's very interesting. Everyone's good at physics. I mean, honestly, like, I'm not even the best physicist. Like, people, sometimes, oh, you're so smart, Dr. Gold. I'm like, not really. Like, I did get a PhD, but within my PhD class, I was kind of like dead last, honestly. Like, I like barely, I was the cutoff for passing. But what makes me different, so I'm not the absolute smartest physicist, but I'm the best at explaining it. Because most of the kids in my class who were very, very smart were like not very good at explaining what they were able to do. And so it's just like, it's kind of useless to me at that point. Like, well, it depends what you want to, to me, it's like, if you can come up with the most brilliant stuff in the world, but you have no way of explaining it, it's like a bear shitting in the woods. If no one hears it, did it really happen? Like what?
Yeah, in the future, I thought maybe we can do some like Q&A kind of session, or maybe
Yeah.
like do an introduction to like different areas of physics
Yes.
as
Yeah.
well, because like there's a lot of like cool different ones, and then maybe people get some idea of like what they would study if they were to go into physics or something.
Yeah, no, I think that'd be mad cool. I really do. Yeah, that would be super cool. I'd love to learn about your plasma physics. Yes, we'll do a session. Yeah, I'm gonna do it. I wanted to do the podcast this Thursday, but man, everyone's had final exams this week. I taught for like 12 hours yesterday, so next week will be much better. Yeah, I know. I taught chemistry. I taught physics. I taught calculus. Man, yeah, I taught a lot of stuff yesterday, and I'm kind of exhausted. Okay, but anyways, getting back to what we were doing here. So, these are the three things. Mainly three. There are three variables that you're really going to look at: the pressure of a gas, the volume of a gas, and the temperature of a gas. Right? Let's say, for instance, yes, you have your water bottle, right? And you've just emptied a bunch of hot water out of it. Okay. Like you just dumped all the hot water out. What's the temperature of the air going to be inside the water bottle? Like approximately.
What do you mean?
Like is it going to be hot? Is it going to be cold?
Hot.
Yeah, good. Temperature's hot. Like you had hot water in there. You emptied the hot water, but because the water was hot, the air that came back in got heated up, right? So it was also hot. Okay. And then you sealed it. Okay. Now, what happened, like, sometime later, is that the air inside the water bottle started to cool, right? Because the air outside the water bottle, right, your environment is colder. And so that will cause heat to leave through the plastic in the water bottle, right? And so what's going to end up happening to the air within the water bottle, is it going to get, like, hotter or colder, Nick?
It's gonna get colder.
Good. Gonna get colder. Okay. So let's look at our equation here, though, right? Okay. So PV equals nRT. This says that the pressure and the volume of a gas is always equal to these things times the temperature. Okay. Now let's see what happens. If, for instance, the temperature goes up, but I need both sides to still be equal, what's going to happen to the pressure?
It would also go up.
Good. As long as the volume was constant. As long as volume stayed the same. Because your water bottle is solid, right? It's not really changing. We're going to assume the volume is more or less the same. Okay. So now what would happen if the temperature went down? What would happen to the pressure?
The pressure would go down.
Good. Yeah. And actually the pressure and the volume can kind of both go down, right? And the volume probably does go down a little bit. That's why the bottle like compresses, right?
Yeah.
But in reality, what's happening is like your air inside the water bottle was hot. It's sealed, right? So you're not allowing any more air to come in or out. If this was unsealed, well, I'll explain what would happen. But because it's sealed, right? When the temperature goes down, that means the pressure of the gas inside has to also go down. And if the pressure inside is less, right, than the pressure around it, like the atmosphere, it's going to compress. It's going to feel like it's getting crushed, you know?
Damn.
It's the same way. Have you ever like taken like a water bottle and like, I don't know, you like try to suck all the air out of it and it goes, and, like,
yeah, like space.
Good, like space, yeah. That's you decreasing the pressure within this what is it, this water bottle, and because the pressure is less than the pressure outside, it crushes it. Like it goes meh. Yeah. If you had left the cap open, what would have happened is as the air cooled down and technically the pressure would go down, it would equilibrate with the pressure outside of the water bottle because it's open. So it's not gonna implode on itself because it can always like suck more air in from the outside to equal out that pressure. Yeah. Anyways, does that make more sense? That's a very good science question. I like that. That was a very good just conceptual question. I'm a fan of that one.
I was
Nice.
so lost. In front of my eyes, it was just getting smaller and smaller. I was so
Yeah,
confused.
yeah, that's cool, man.
Yeah.
It's you'll also
Within
know.
a second, it went fully down.
Have you ever? This is another good question. Have you ever bought like a bag of chips somewhere and then like you travel like in a road trip and like say you go somewhere else and then you notice that the bag's like about to explode, right?
No, never.
You've never noticed that? No? Or like,
No.
well, try this sometime, you
I
know.
think I've seen it before, but no, I never.
Yeah, so this is another cool thing. So chips, right? When chips are bagged, it's a sealed container usually, right? It's a bag of chips is sealed, right? Wherever they're bagged, right? They have a certain the pressure in the air is a certain amount, right? There's a certain amount of air inside the bag of chips. If you start going to higher elevations, so say you drive up to a mountain, right? The pressure, the atmospheric pressure up at the top of the mountain is less than it is down at the ground. And what that does is that causes the air that's trapped within this bag of chips to be greater in pressure than the air around it. So the bag of chips expands. So it almost looks like it's going to burst. Pretty cool thing. You can try sometime. Yeah. Next time you're going on a road trip, buy a bag of chips. And then, if you're going up or down, look what happens to the bag of chips. It's pretty cool. Nice.
And also buy a gold calculator.
You could also buy a gold calculator. Yes.
That's dope.
Anyways, good question, Nick.
Yeah.
Appreciate that one. That was good. All right. Let's see. Next up, we got Ethan. Ethan, what's up? Oh, oh man, I need to make a TikTok video on this today. The company I work with, I've written the script for it, but I need to record myself doing this one. This is a very good one. Ethan, come up to the stage. I think you should be able to just come up as well. Or this is another thing, Ramit. If you see people that are raising their hands in the Discord, I don't know if you're in the Discord or in the Twitch primarily, but you can also just like let people up if I don't get to them. I'm gonna go through all these things.
Oh, I always want to ask you if I should or not.
You can always come up. No, you're fine. If you're a mod or whatnot,
I'm
you
saying
can.
for other people.
Oh yeah. Yeah, it's kind of like a use your judgment thing. Like if I'm in the middle of teaching something, then like don't let people up. But if I'm not, and if I'm just like talking and whatnot, yeah, you can let whoever up. What's up, Ethan? How's it going, dude?
Oh, okay, cool.
I'm good.
Good, man. Sweet. Oh, this is a velocity versus time graph. This is cool. I did a video on position versus time graphs for TikTok. I need to do a velocity versus time graph one. But this is good. Okay, this is physics. You're getting into physics here. This is back-to-back physics questions. I like this. Fine.
Physics has a lot to do with math, you know.
It does. Actually, they say that like math was created for physics, or calculus was created for physics. Like Isaac Newton was like trying to describe the world using physics, and he was like, I need better tools like with numbers to describe this. So he created calculus, or he created the framework for what calculus would become. It's pretty cool.
Okay.
So here we have a velocity versus time graph, right? Do you remember what velocity is?
The velocity is how fast something can go.
Good. It's called, how fast something can go, which is like the speed, but it also includes a direction, technically. All right. If your mom tells you to like run at like 10 miles an hour, you're like, cool, but like where should I run? That's why you need a direction with velocity. Velocity tells you how fast and also which direction. Okay. In this case, this is what we call a one-dimensional direction because the direction is either positive or negative. Okay, you're either going to run positive, which is usually like to the right or going up, or you're going to run with a velocity that's negative, which is either to the left or going down, depending on like whether we're going up, down, or left, right. Okay. Okay, so here it says during which period A, B, or C is the car slowing down? That's a good question. What does it mean for something to slow down?
It means that whenever it was going at its normal pace, it starts to like stop for a bit.
Or
Right?
it starts to go slower, is what we say. So for something slowing down, okay, that means that the change in velocity divided by the change in time, but yeah, don't get too hung up on that. Just the change in velocity we say is negative. Is what we say. Like velocity is going down. That's what it means for something to slow down. Okay. This also corresponds.
Okay.
This corresponds to something, another term we're going to learn, which is called acceleration, which is equal to the rate that you're either slowing down or speeding up. So it's the rate of change of velocity is what we say. Okay.
Alright.
This is a velocity versus time graph, okay? So, slowing down means that, in this case, if we're only in one dimension, it means the acceleration is negative, okay? So, that means that this, delta V over delta T, is going to be negative. Now, delta V over delta T, if my graph is V versus T, what if my graph was Y versus X? What would be delta Y over delta X in terms of like a graph? What would that be?
Wouldn't the y be positive this time?
Yes, but in math, when you do like the change in Y over change in X, you guys also call this like rise over run. What is that? What is this usually on a graph?
I really never learned that. I
Oh,
really
okay.
don't understand it. I mean,
It's okay.
like I don't understand it.
Did you ever calculate the slope of a line?
I feel like I did.
Yes. Okay, cool. The slope of a line is always what we say is the change in Y over the change in X, or the rise over the run. Yes, rise over run teacup. Yeah, that's what they also call it. But yeah, so that's when it's Y versus X. This is V versus T. So the same thing. The slope of this graph will end up being what we call the acceleration. Okay. So when they ask where is something slowing down, they're asking what part of this graph is the slope negative.
Alright.
So what part of this
Well, I
graph
think-
is the slope negative?
Is it C? Maybe
right.
C.
Yeah, right here. You see how here it's like going down? Yes, that's negative. That's a negative slope. Yeah, Dark Aspect says, yeah, upright or downright. Yeah, it's you're either going up and to the right, that's a positive slope, or you're going down to the right, that's a negative slope. Correct. Okay. Good. So that's C. All right, so speeding up. So if slowing down is when the slope is negative, what do we think speeding up is going to be?
When it goes up.
When it goes up, yeah. That's going to be when the acceleration is positive. All right, so where do we see here that the acceleration is positive?
It's on A, right?
A. Technically, this part as well, but they just didn't label this. Like, what? Why did they should have labeled this part. I would call this like part D. But I guess it's not labeled, so right. Yeah, that's just going to be part A. Okay. All right, next question, is when it's traveling at a constant velocity, okay? What constant velocity means that the acceleration is 0. Reason for that, Ethan, right? Remember, acceleration is the change in velocity over change in time. So if the velocity is not changing, if something's constant, it doesn't change, then this is going to be 0. Okay.
Alright.
So where here is the slope equal to 0?
I really do not know. It could be A or C.
Well, no. The slope was positive at A, right? Because it was going up. And the slope was negative at C because it was going down. When the slope is 0, something is flat.
Yeah.
Where is it flat?
Oh, is it B?
Yep. Good. All right. What is the fastest velocity at which the car travels? Okay. How do you figure that out? That's a good question.
Go. I want to say the question again.
What is the fastest velocity that the car travels?
I feel like it has to do something with multiplying time and velocity or something.
No, that gets you distance. Yeah, velocity times time, that gets you distance. We don't need that. That's okay. That's another physics concept. No, let's remember, Ethan, this is a graph of the velocity versus the time, right? So, if I want to know the fastest velocity, right, I just need to figure out where this graph is the biggest V. Where does this graph have the biggest V?
It's between B and C, right?
Good. Yeah, it's right here. So what's that amount? They want to know what that amount is.
Is it 20 milliseconds or something?
20 meters per second. Nice.
Oh.
Nice. Good job, Ethan. The second part asks you to convert that to kilometers per hour. Let me do that on another day because I want to get through everyone's questions. But yeah, that's units
That would
conversions.
take a whole. That's like taking a whole 30 minutes or something.
It would take another 5 or 10 minutes, and we're already at 5:38. So I got to get through everyone's questions today. This is why Ramit's right.
Right.
We should have a podcast section. Maybe you know what we should do. Maybe. I do want to do the podcast on a separate day, but I think it would also be cool to maybe sandwich them. Like, I wonder if that's too long to like do a podcast and then do teaching. What do you think, Ramit?
What would you do on the
like
podcast?
2 hours, you mean?
Yeah, because there is something to be said for the longer that the stream goes on, the more people find it on Twitch. So that is definitely
That's
like
true.
it's a bet. Like I've noticed that recently with these streams where we go way over an hour. We're going to an hour and a half, hour and 40. It does start picking up. Like the more you stream, the more people find you, which is cool. The only downside is I get fucking exhausted.
I guess what you
Yeah.
could do is like you can do the first hour
Mm-hmm.
to like go through the questions and everything, because everyone who was gonna be on the stream in the beginning are the ones who are gonna be asking the questions anyways.
I see. It's
And
like
then-
seeding it. It's like seeding the pot.
Yeah, and then you're kind of like using your mental thing for like solving questions in the first hour, and
Mm-hmm.
then the second hour, which is going to be more relaxed, that's when the viewers are going to also pick up. So
Oh,
then
okay.
doing the podcast after, then it might like be like, oh, after a bunch of people have already joined,
Yeah.
those people might appreciate the more kind of casual aspect of it as well.
No, I like that. Okay,
I
that's a
don't
cool
know,
idea. Yeah, it's again, and like anything, you have to just experiment. We just have to experiment and try with things. I like the idea of adding more days because I know streaming more regularly always does well. But then I'm also a fan of like streaming for more time because yeah, you're right. Because more people find it and then they kind of just join in. Noise says you should allow for 10 minutes of linear algebra worship every stream.
I second that.
Yeah, but what would you do on the podcasts?
All hail King Vectors. There are a couple ideas. Ramit brought up some good ideas where we could maybe go into like little mini lectures. Like he could talk about like what he does with like some stuff with computational physics or whatnot. I could talk about my plasma physics degree. We could do an AMA where we just like answer anybody's questions about random shit. Like that's cool. Another idea I had
If you
because
make this, invite me right away.
of course, no, you would all know about it for sure. But also, I mean, I live in LA. It's very easy for me to like get a hold of someone who just wants to talk about like whatever. I could start bringing on like live guests to also like you kind of like a Joe Rogan type thing, you know, where like you have some expert come in and talk about some stuff and you just chat it up, you know. It's cool. It's a cool idea. I like it.
Hey, that's a goal.
What's up, bro?
Definitely will join.
What's up?
Hey, that's a goal.
Yes.
Yeah, I think that would be a nice idea considering like we do have some understanding
Sure.
and then we like know the kind of audience and then
Yeah.
when they explain something and if it's too complicated, we're like, oh, let's just like bridge the gap between
Yes.
something that might sound way too complex between like we know that most people are going to be in like high school or like
Right.
first year universities.
Yep.
What's the leap we kind of have to like make for everyone to understand?
It's like translating too. You know?
Yeah.
Right? It's a lot of times what I do here is there are like cool topics that like, you know, I understand, you understand at like, you know, the graduate, postgraduate level. But being able to find like the analogy that makes sense to a kid who's like 13 or 14 being like, "Oh, this is like, you know, the pump shotgun in Fortnite." They're like, "Oh, okay, I get that."
Nice.
All right, what's up, Teacup? Teacup, let's do your question. Let's roll through them. Let's roll through them, buddy.
Well, you know,
What's up, Ethan?
that's a goal.
Yes.
You know, I technically have like 100 coins now.
Do you? Oh yeah, once I add all of them. Yeah, no, I'll get it to you. Yeah, congrats, dude. Yes, you'll get to pick a prize. Let me add all of them. Once I add all of them, yes, you're good.
But what about the sold out things? Because those you still haven't fixed that.
It still says it's sold out on the thing.
Yeah.
Check it. I think I'll manually go in and fix it. Don't worry. That's whoever the developers are for my point system are lacking in some regards, but it's okay. I'll they're not bums. I mean, like I pay them $1 per month on Patreon. Yeah,
Yo,
Teacup, come
you
up.
should pay us as well.
Yeah, I should. Yeah.
Every week.
I already pay you guys in Fortnite gift cards. I'll chill.
No.
What's up, Teacup? Teacup, or he was a speaker, then he came down and he went when he's no longer a speaker. Come back up as a speaker. Teacup. Teacup, you know how to do this question too. This one's like dumb easy. Can we get him back up? Maybe he's having some technical difficulties. Here. While that happens, I'll get Bob's up.
Chicken nuggets.
People can get Fortnite gift cards. Yes, they can. Noise. Yeah. That's so noise. That's the original like funnel for how I built this Discord. And honestly, like how I want to build this Discord is I want to create the same sort of like reward system that like students that the same sort of reward system that people are used to in like video games, like grinding to get points and levels and whatnot, but just doing it in real life. And so it's kind of like blurring the lines between that. Yeah. And I've done it. Yeah, it's that was the original thing. I was like, "Hey kids, do you want to earn a Fortnite gift card? Join this server, get help with your homework, complete some challenges, and then I'll give it to you." And like it, oh man, kids love V-Bucks, dude. They will do literally anything for V-Bucks. It's like it's scary. So I have them do math questions for V-Bucks. Is basically what that's how I built this Discord. Yeah.
So I'm just literally thinking if I should take the or the headphone.
Yeah, well, we'll debate it. They're two things. Okay, here. Let's get through questions real quick. Well, we got a lot of questions. We're gonna go over time today. It's okay. It's okay. Maybe I'm just gonna say the office hours is now an hour and a half. I like it. All right, Teacup says he can't join. Kudu, where are you at? Yeah, we're gonna get the Kudu back. Okay. All right. This is a cool question. I'm gonna make this one slightly harder. I'm gonna say this is 3x squared minus 27 is equal to 0. No, it's okay, Teacup. I'm gonna make this harder, but I'm gonna to show something. Okay. How would we solve this, Teacup? What would you do? Because I'm gonna show a trick with this. You can also chat in the office hours. Is probably faster to chat it than Twitch. Divide. Ooh, yes. Yes, good. Oh, wait, no, sorry. Correct. Yes, you can divide by 3. You can divide both. You can divide everything by 3 because this has a 0 divided by 3, right? Because that would end up being x squared minus 9 equals 0. I'm doing math while grinding points. Yes, that's what happens. Okay. What do we do next? Ugh. Oh, I forgot to drink coffee today. A minus B. Yes. Oh, are you going to do the trick, Teacup? Do you see it? Do you see the trick? A minus B times A plus B. Teacup! Yes, dude, you made my day, man. Okay. Teacup's bringing us up a very good point here. So I thought what Teacup was going to say, because this is the general way to solve algebra questions, would be just to add 9 to both sides. That you get x squared is equal to 9. And then you would square root both sides, right? And you would get x is equal to plus or minus 3. It's all fun and games until x squared plus 9 equals 0. Yeah, then things get imaginary noise. And we're like, oh, shit. But yeah, this would be the traditional way to solve it. Key thing here to notice, guys, whenever you take the square root of both sides, you got to make this a plus minus. Like, a lot of kids will see this and they'll just be, oh, square root of 9 is just 3. And they'll just be, oh, x is 3. Not right. It's plus or minus 3. Because minus 3 times minus 3 is also equal to 9. X equals 3 just by itself. That's called the primary root. And actually, Ramit, I have a good question about this. Because I think this is probably something that goes a little bit more in depth to math. Because I've had this, for instance, where I've been teaching like 5th graders or something. And their teacher will be like, what's the square root of 81? And they'll say the correct answer is 9, but I'll say, no, it's plus or minus 9, right? Am I technically correct here? I think so.
I think that the answer to the square root is only the positive, the
Interesting.
convention. But then when you have like a square of something equals to something, then that's when the plus minus. So like x squared equals to 9 is like, because the value, you're looking for the value of x squared.
Yes.
It's like, then x could be plus or minus 3.
I
But
see.
then from the square root, then technically, like on a technicality is like right. But the only thing is like, it kind of breaks down math because you can always say it's minus 3 squared. And then you can do, it breaks, commutativity or something like that. 'Cause,
Commutativity,
like, you
yeah.
can always get like eyes out or something like that. It's just weird because like you can split it into square root of negative 3 times the square root of negative 3,
Uh-huh.
and then that would become square root of 3i times the square root of 3i, and then you would get
You get negative 9.
yeah, I would be out of the thing, then which would be negative, and then
Yeah.
you would get
Yeah.
negative or something like that. Yeah, I think.
Yeah, I remember going through this at one point. I was like, oh shit, wait, no. Because yeah, then I get like, oh, 9 equals negative 9, and I'm like, nope. That's not good.
Yeah, I think it's because they want to make math complete. This is something
Complete.
like
Mhm.
in like analysis or something, just to make sure there's always a unique answer to the same
Yes.
thing.
Right.
Yeah, I'm
I
not
see.
an expert in those things, but if someone knows like abstract algebra, they probably know, or
They
like
would
not
know
even
why.
algebra, like category theory or something like that.
Or yeah, it's and that's cool. That's cool. Yeah. This is one of the things where like I know there is some underlying like higher level math reason why we don't do that, but yeah, that's cool. That's what it is. Yeah. Okay.
Yeah.
All right. So yeah. So guys, yeah. When you do the square root of just regular numbers, it's just the positive one. This is us. This is the translating. This is translating the higher level. Oh, commutative rules with imaginary numbers and blah blah. It's like it's just use the positive one, guys. But if you're solving, for instance, x squared is equal to 9, now you have to do plus or minus 3, because negative 3 squared is equal to 9, and so is regular 3 squared. That's also equal to 9. That's where that comes from. Yeah, I knew there was something underlying that was like screwing with that. But anyways, Teacup was especially smart here though, because he came up with a different way to do this, in which he noticed if you have a squared minus b squared, this is the same thing as a plus b times a minus b, which in this case, a is going to be x, and b in this case is going to be 3. So this is the same thing as x squared minus 3 squared, which is the same as a plus b, so that's me x plus 3, times a minus b, x minus 3, is equal to 0. And now this right here is a cool question where we just solve each one of these individually, because if this is equal to 0, I don't care what this is. Whole thing goes to 0. And if this is equal to 0, I don't care what this is. Whole thing goes to 0. So this is where we get x could be -3 or x could be +3. Nice. Good question, Teacup. I like that one.
Nice.
All right, let's roll through it. Next up, Bob. What's up, Bob? Come up to the audience, Bob. Your question. Looks like we're gonna do stuff with trig. I see some trig stuff coming up. I see the trig. Can we get Bob up? On the other ones too while we're at it, because then we're gonna have Minions gonna have a question. The apple, peach, or the pear. I like that one. That's a good one too. All right, let's pull that one in. That one eventually. And we got Noise with the calculus. Love it. Oh, we got Kosh. You can do we're gonna do hyperbolic cosine here, dude. Damn. Okay. I was just literally just teaching this, and then equity is gonna have that. Cool. I'm gonna pull that one in too. All right, let's go back. See if Bob's here. What's up, Bob? How's it going, man?
Good.
All right. I saw you. Are you keeping your A in calculus? You're like an 89.5, right? You're like right on the border.
Oh, it's back to 90.00.
We'll take it. We'll take it. Nice, dude. All right. Let's see. Find all x values on the graph. F of x is -3 sine of x cosine of x, where the tangent line is horizontal. That's cool.
And then the answer is there, but I don't know how to put the answer.
Yeah, that's okay. That's cool. All right. So tangent line, all right, is horizontal. If a line is horizontal, what do we know about that line?
F prime is equal to 0.
Good. Yeah. It says the derivative, right? The slope is equal to 0. Ethan, this
Yeah.
goes back to what we were talking about. Remember when we had like y versus x or whatever, y versus x. The slope of a horizontal line is 0. Okay. Cool. All right. So I need the slope to be equal to 0. Which means I need, and the slope is the derivative. That's how calculus works. So f prime of x, which in this case is going to be a product rule, right? Love it. So this is going to be -3 cosine squared x, and it's -3. Keep that one, but then it's plus, and then it's sine squared of x, right?
Wait, how'd you do that so quickly?
Yeah, okay, all good. I'm going to pull the -3 out. So the derivative of a times b is a prime b plus b prime a, okay?
Yeah.
So the derivative of sine is cosine times cosine again is cosine squared. Then the derivative of cosine is negative sine times sine again, so that's sine squared. And then we had a -3 attached, so that's why this became -3 and this became +3. Cool?
Okay. Yeah.
Okay. Damn, it's so close, man. I wish it was sine squared plus cosine squared. Do you know what sine squared plus cosine squared is?
1.
Good. It's another identity.
Yeah.
It is 1. It is 1. You're good. Okay. I need this to equal to 0. Great. Okay, I'm gonna pull the 3 out. This is sine squared of x minus cosine squared of x, right? has to equal to 0, so I can get rid of the 3s. We don't need the 3s anymore, right? Can I just pull those out?
Yeah.
All right. Oh, okay, this is cool. So I need sine squared to equal cosine squared, basically, right? Okay. This you can kind of do this from the unit circle, right? Where is sine and cosine equal to each other? Like what angles do we have sine and cosine are the same?
Pi over 4.
Good, right? Because when we're at pi over 4, that's when this is square root of 2 over 2, square root of 2 over 2, right? Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, right? Okay. So that's a case where sine and cosine are the same, right? That also happens down here, right? Because here sine is negative square root of 2 over 2, and cosine is negative square root of 2 over 2, right?
Yeah.
And then even more so, okay, one sec. Why is it only the odd ones? 2n plus 1. Oh, I know why. Sorry, my bad. Okay. Because it's sine squared and cosine squared, these ones are also going to work, right? Because sine squared is it's going to square the negative to make it positive, and then sine squared will already be positive if we're in this quadrant, but the cosine squared squaring it will make that positive as well. Do you see that, right?
Yeah.
So it's basically all the 45s for the reference triangles, right? So that's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4.
Yeah.
And so on, right? Okay. So there's a pattern to this. Do you notice any sort of pattern that's happening?
It's every 2. It's every pi over 2.
Pi over 2 is the spacing. Yes, that is true. That is very true. It's pi over 2 is the spacing. The other thing I kind of notice here, right? Do you see how this is 1, 3, 5, 7, 9, blah 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 blah, right?
Yeah. Every odd number.
All times good. Any odd number, right? Okay. Now here's these are good things to learn, especially when we start getting into sequences and series. You want to learn how can I express something that only hits all the odd numbers? Do you know how to do that?
Add 1. I mean, add 2 every time.
Add 2.
Oh, that's
right.
the 2n.
That's the 2n plus 1. Anytime you want to pick out odd numbers, you use 2n plus 1. Because when n equals 0, right, this is 1. N equals 1, it's 3. N equals 2, it's 5. So this is a cool, like, combinatoric, I don't know what the name for it is, but it's like, it's a cool computational way of picking out odd numbers, is to use 2n plus 1 for all n.
Is it just 2n?
Pardon?
If it's even, is it just 2n?
Yes, exactly. Yeah. And if you want just the even numbers, it's 2n, right? So I know it's 2n plus 1 times pi over 4, right? Which is basically what this is.
Oh. Okay, I see.
Cool? Nice, dude.
Yeah. Thank you.
You're very welcome, dude.
Nice.
Just to and then
Yes,
do you
Raymond,
mind
what's
if I
up?
Add something.
Please do,
Yeah,
please do.
so one thing I also like to, depending on what you're more comfortable with, whenever I see sine x cos x, you can turn it into like a sine of 2x over 2. And then you
Ooh,
only
the
have to
double
deal
angle
with, like,
formula.
Yeah, and then you only have to worry about one trigonometric function to worry about. So
Yes.
it's less trigonometric functions to worry about, but like with the double angle, if you can see it, then sometimes it makes it easier.
I think, yeah, you bring up a good point. I think that the issue is that nobody remembers the double angle identity. Like, I don't even remember it. But if it's given to you, it's good. Because this was sine squared minus cosine squared, right? That's what it was, right?
Yeah.
We'd sine squared was equal to cosine squared of x, right? Basically.
Yeah.
And then actually, sorry, and you turned this into a double angle, is what you said?
So you know how in the beginning you have 3 times sine x cos x?
Yes. Oh, you're talking about
You
right
have
here,
sine
way
x
over
cos
here.
x. Yeah. Just at
Okay,
the
my
very
bad.
beginning.
My bad. Yeah. Okay.
So if you have sine x cos x, if you have sine of 2x, right? Then sine of 2x is 2 times sine x cos x.
Oh, this identity. Oh, that's dope.
Then if you divide both sides by 2,
Mm-hmm.
then you have your sin x cos x term, and now
Yeah.
you only have to worry about when sine is equals to 0.
Got
Which
you.
Makes the then you can also throw away the over 2 because
I see.
you
Yeah,
just
yeah, yeah.
now you only want to figure out where that's 0.
Yeah, I see. So what you're doing, you're replacing this with like, okay, 0 is equal to minus 3 over 2 sine of 2x. And then, yeah, I don't care about this,
Yeah,
right?
and
This goes
then-
away. And now I need sine of 2x to be equal to 0, right? Oh, that's a cool trick. D-Ram, that's cool, man. That's a shortcut. It's a cool shortcut. I don't know if I would have remembered that one. But yes. Because now
it depends on how comfortable someone is with
trig. Yeah. I was scared shitless by trig when I was in high school. Like, anytime I saw sine or cosine, I was like, no, I don't want to do it. But this is cool, yes, because then you're asking yourself, where does sine equal 0? Which, you're right, that happens every n pi, right? Right?
Every pi over 2, or every pi over 2 plus n pi.
Pi over 2 plus n pi. Wait. Sine of 2x is equal to 0.
No. Wait.
No.
Sorry,
No. Sine of theta is equal to 0 at every n pi, right? So then I'm saying that 2x is equal to n pi. Oh, we get a different answer here, though. Then this is x is equal to n pi over 2. Let me see.
Wait. Did I mess something up here?
I think maybe this identity is wrong.
Yeah. Maybe.
Let me think.
Yeah, I'm missing something.
Like sine x, no, sine x, cosine x, definitely. Oh, it's 1/2 sine. No. You're right, dude. What? Wait, excuse me. Right. Sine x, cosine x is 1/2 sine 2x, right?
Yeah.
Oh, that's when f of x is equal to 0, not the derivative.
Yeah.
Yeah, I see. Yeah. If they were just asking where that was equal to 0, that would make sense, yeah. But when we get to the derivative, we get to this, right?
Yeah. Yeah, that's true. So then when we take the derivative, it becomes cos 2x.
Good, exactly.
And then that's why.
Exactly.
And then that's why it becomes n over 2. Yeah, that's.
Yeah, because
we skipped it.
We did. I skipped a step because this is sine of 2x, and then the derivative of this is negative 3/2 times 2 cosine of 2x. Okay, cool. Okay, that makes more sense to me. Yes, cool. All right, awesome.
Yeah, and then we do the same.
Yes, very cool. 2 ways to do it, Bob. Whichever one feels more comfortable to you. I like the visual stuff because I'll never forget the visual stuff. But if you can remember the trig identities, it's useful. But not 100% necessary. Depends what you want to do. All right. Minion. Where's Minion? Where's Minion? Exploded Minion. Is he online? I don't see him online. Where's he at? Yeah. Unicircle for the win. Yes, dude. I love the Unicircle. I just say I don't like memorizing the unit circle, but I have a cool way of knowing how to always determine any angle on a unit circle. I made a TikTok about it. I'll show it at some point. But yeah, the unit circle is cool. It's something I was really, like, again, not comfortable with when I was in high school. I wish there would be some more donor plays. Turkish donor does go hard. Yeah, I miss Germany. Germany's got some great donor. There used to be a place in Westwood, Sam. It used to be called... I think it's shut down though. Like any restaurant around UCLA, like it has a lifespan of a maximum of like 2 years. That'd always be trendy. All right, Minion's not here yet, so let's roll over to Noise. Yes, awesome. Okay, cool. Here we go. All right, Noise. An engineering student makes a miniature arch as the part of a design for a piece of coursework. The cross section of the arch is modeled by the curve. That. Oh, Jesus. Okay. Ramen, I might need you on this one. It's like, oh no. Cosh 2x minus ln of a to ln of a. Okay. Curve begins on the x-axis. Okay. As shown. All right. Show that the length of the curve is stating the value of the constant a. Okay. I think I remember the equation for length of a curve, right? Is that arc length, right?
Yeah, it's like the square root of 1 plus y prime.
Yeah, okay.
Squared.
Yeah, so arc length goes from the x1 to x2, and it's the square root of 1 plus f prime of x squared dx. That's the equation for arc length. Or
Yeah.
curve length. Yeah. Where this comes from is actually pretty cool. It has to do with it's like you build like a triangle like around the slopes and something like if you have this, right, like the derivative of this is some amount, and then it becomes like a Pythagorean theorem. We can do this on another lecture. That'd be cool actually to explain where that comes from. I've seen it before. It's cool. All right. Here's our function. First thing to do is take the derivative. Derivative of a constant is 0. Derivative of 1/2 cosh of 2x. Great. Is the derivative of cosh sinh? I think it's sinh, right? Remember.
Yeah, like they just go back and forth. So it's the nicer of the trigonometric identity.
Yeah, because all the other ones like suck. But
yeah, they just you don't have to worry about minus for this one.
the nice thing is this is gonna be a chain rule with the 2x, cancel out the 1/2. So I'm left with what I believe is gonna be 1 plus sinh squared of x, right? Dx.
Yeah.
Yeah. Okay. Cool. That's not bad. Not terrible. Okay. And then 1 plus is 1 plus sinh squared equal to cosh squared?
I think so. I have to check that.
Yeah, I gotta check. Yeah, this is going into my what was it? Cosh sinh identities. It's cool. Where the fuck is that identity? Yeah, 1 plus sinh squared is cosh squared. Okay, cool. So this whole thing becomes cosh squared. Square root of cosh squared is cosh. So now I have the integral from negative ln of a to ln of a of cosh of x, which this I believe is an identity that I should know, but I teach so many things. I can't remember them all. Integral of cosh is sinh. Oh, okay. That's cool. So this is just sinh from negative ln of a to ln of a. Okay. Sinh has a definition, I think, in terms of e, right? I'm trying to do this without a calculator. I could just plug this into a calculator and do it.
It's e to the x minus e to the negative x.
That's it? It's not over 2i or anything?
Yeah, there's a line over 2.
Over 2? Everything's over 2? Yeah, I thought it's something like this. Yeah, this is cool. You can always express the sine. You can express all these trig functions, sine, cosine, and whatnot, using different e to the x's, e to the ix's. There's a whole definition of these. Is it trig e to the x identities? Yeah, it's all these. These are all very cool. Cool things to know. Because you can brute force. It's pretty cool. You can brute force all the trig identities by just knowing exponential rules with e to the x, if you really want to. All right. So let's see. Let's go back. Okay. So I'm gonna plug in ln of a. So that's e. Okay, and then e to the ln of a is just equal to a, and then e to the minus ln of a is 1 over a. Is that right? I think that's right. So that's going to be a minus 1 over a over 2 minus 1 over a minus a over 2, I believe. A minus minus plus, so that's 2A minus 1 over A plus 1 over A. These are going to cancel. Does it just equal A? Oh, no, I fucked up. Wait. Oh. No. No. Where did K come from?
I think K is supposed to be like just some factor in front.
Where did that come from, though? I thought we were just doing a simple integral.
Yeah, it's e to the.
Where did I fuck up here? You know, sometimes I'm just like,
Well, I can.
arc
Yeah, I
length.
can just check the integral of this, anyways.
Yeah, right. I'm just gonna do. Oh, you know what? Oh, this is where I fucked up, dude. Sorry, I took the derivative. I got rid of this. Wait, no, that's okay. Yeah, no, the derivative. This goes away. It's okay. What did I do wrong? What did I do wrong here? No. X minus. Let's just say A minus 1/2 cosh of 2x. I shall have Wolfram do it. Wolfram shall get it. You can't figure that out, dude. Wolfram, you can't figure out arc length, dog? I know you can. You're smarter than that. Okay, fine. Okay. First thing we do, derivative, right? Of 1 over 2 cosh of 2x. I think I did that right. Sinh of 2x. Cool. Oh, did we remember the 2x? Oh. Maybe that's where I screwed up.
Oh.
Yes. Yeah, that's where I screwed up. That's where I
Yeah,
screwed
it
up.
was the. It's supposed to be sinh of 2x, not.
Yes. Yeah, sorry.
Yeah.
There's a 2. There's a 2
Yeah.
here. All good.
Yeah.
Okay.
There we go.
Okay.
Yeah, and then
All right.
the 2 will fix everything.
Yes. The
So
2 will
then
fix
it'll be
everything.
e to
Yeah.
the 2x.
Right. E to the 2x. Right. Which is the same thing as e to the x squared, right? So this is the same as e to the ln of a squared.
Yep. And then it becomes a squared.
A squared, a squared, a squared, a squared, right?
Yeah.
Okay, cool. Okay.
I don't think they add up also. They just
You're right. Sorry.
they don't.
It's this, right?
Yeah.
Cool. All right. Good. Yes. Sometimes. Yes. Okay. There you go. That's it. That's where like there's a slight mistake that like messes that up, but like yeah, it works. Okay. Cool. All right. Stating the value of the constant k. K equals 1. I think k is just 1, right?
Yeah, I think that just makes K1.
K equals 1. Okay. Cool. The length of the curved cross section of the miniature is required to be 2 meters long. Find the height of the arch according to this model. Oh. Okay. Okay. Oh, I see. We're just gonna set this equal to 2, right? Because we figured out the length of the arch is a squared minus 1 over a squared, and we want that to be equal to 2. So multiplying through, I get a to the 4th minus a squared is equal to 2a squared. Not a squared, sorry, minus 1. So that's a to the 4th minus 2a squared minus 1 is equal to 0. I'm going to say that a squared equals x. So x squared minus 2x minus 1 equals 0. x minus 1 squared. So x is equal to 1, a is equal to 1. Okay. Cool. That helps me. That helps me
No, I
out.
think that it has to be the last one should be +1.
Oh,
for the
you're so
identity
right.
to work.
Oh, you're right. You're right. You're right. Oh wait, then how does? Oh, this isn't. Oh, this isn't. This isn't. Yeah, you're right. That had to be +1. So
Yeah.
this isn't factorable, right? I think it is.
I think so. So maybe just using the quadratic.
Yeah, I think we have to use the quadratic. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 2 plus or minus, was that 2 root 2 over 2? 1 plus or minus root 2 is equal to x. But then we square root it again, which is a squared, right?
Yeah, this has to be equals to a squared.
Uh-huh.
But then the negative one gets
Goes away, right?
Rejected because
Right.
a squared can't be removed.
So a is equal to the square root of 1 plus the square root of 2. Gross. Super gross. Okay, that's a. So they want us to know the height. Okay. All right,
Just
I think
plug in like x equals to 0.
right. Well, y
Yeah.
equals to 0, right? Oh. Well, we have to solve now for what big A is though, right? Using our new bounds, because I think what's happening, right, is we're getting we're getting something like this, right? This is our new like square root of 1 plus square root of 2.
That isn't that just the oh, okay, I see.
Right? That's the boundary points, right? That's what this would be.
Yeah.
Because this is a minus 1/2 cos 2x. So I need to know what this is. Oh, I see. I could just plug in this value, right, to get what that is, and then do a minus that. Is that right? What I want to do.
So which part are we doing? Are we doing C?
Part B.
Find
Find the height of the arch.
at 0. What is cosh at 0?
Cosh at
Yeah,
0
is that-
should be 1. Is that right?
I think so. Yeah.
Cosh at 0 is 1. Yeah.
Yeah,
So
but we don't know the y value.
right,
And we don't know a.
and we don't know a.
Oh, okay.
Right. So
Yeah.
at 0, right, this is equal to a minus 1/2, right? This whole thing here
Or
is
we can plug in y equals to 0, and then since we have the x value according to it, then we should be able to find it.
You mean if we plug in into where? Into here? I should plug the x value in to get the y value? Yeah, and then they'll cancel out. Okay. So I need to know what 1/2 cosh of 2 times the square root of 1 plus the square root of 2. You have to be able to use a calculator for this one. Like, I'm not going to do that by hand. I don't think anyone can do that by hand. Does the TI-84 even have hyperbolic on it? It must, right? Oh, fascinating. Sometimes it's in the catalog. If I go into the catalog, I can find it.
No, I think what I meant is if you plug in. Actually, wait. Maybe you're right.
Yeah, because so here's what's gonna happen. So if I plug in this value of x, right, into my curve, right? So I could either
Yeah, you can put
I can plug that in and set it equal to 0, right? And that will tell me what a is.
it has to be ln of that.
ln
It
of
has to
that.
be ln of that. Because that's where your y equals to 0 is. Because it says x is between like negative ln of a and ln of a. We know the value of
Oh, you're
So-
so right. Okay.
Yeah.
Sorry. So I have to plug 1/2 cosh of 2 ln of all this.
a. Yeah, ln of
The square root of 1
A,
plus the
yeah.
square root of 2. Yes. Okay.
yeah.
Got you. Okay.
And then now you can use the definition of cosh to make that. Do not have to use the calculator.
Oh,
'Cause then it
okay.
would be like cosh of 2 ln, and then it becomes, so the whole thing just becomes 1 plus square root of 2.
1 plus the square root of 2.
Or
No, no,
1/2.
Because
If I can, if I would be able to write it, that might be easier to explain.
Yeah. Here, do you want to write? You can join.
Yeah, if that's okay.
Yeah, you're good. Go for it. This is a cool one. I'm gonna double check with the calculator. I'll let
Do I use the same link you sent me?
Yep.
before?
Yeah, same link. Should work out.
Okay.
Teacup says, how much left
Okay.
in the stream? I don't know, maybe 20, 30 minutes. I want to get this one done. This is a cool one.
Yeah. So then,
Good. Here. You have presenter, so you should be able to write.
okay. Yeah. So this is
Let me zoom.
1/2 cosh. It would be e to the 2 ln of 1, or square root of 1 plus square root of 2, and then minus e to the minus 2 ln of square root of 1 plus square root of 2 over 2.
Mm-hmm.
This 2 comes up here, becomes ln of this whole thing. Then that 2 in the exponent cancels out the square root. So then the whole thing just becomes 1/2 e to the ln of 1 plus square root of 2
Uh-huh.
minus e to the ln of 1 plus square root of 2 to the minus 1
Uh-huh.
over, and then 2. So then 1/4 1 plus square root of 2 minus 1 over 1 plus square root of 2.
Which I think to combine the denominators there, right?
And then it gives us 4 times 1 plus square root of 2, which is 1 plus square root of 2 squared. So it's 1 plus 2 square root of 2 plus 2 minus 1.
Uh-huh.
And then this is 2 plus 2 square root of 2 over 4 times 1 plus square root of 2. Oh, this is going to be nice. 2 times 1 plus
He's like, ooh, this is gonna be nice.
4 times 1 plus square root of 2, which 1/2.
Nice, dude. Yeah. That's a crazy one.
And then this whole thing is actually 0 equals to a minus 1/2. So then
A is
just
equals
1/2.
1/2. Oh, it's beautiful.
Nice.
I always love that when that happens in math, dude. Yeah, so here I'll zoom in so that like maybe you can see it. Noise. This right here was the definition of cosh. You just plugged in 2 ln of square root of 1 plus square root of 2, and then you get some nice identities with when you have powers to powers. If you have e to the a b, it's the same thing as e to the a to the b. That's how this pulls out. And then e to the ln of a is just a. And e to the ln of minus 1, right? That becomes 1 over. And then this is combining same denominators. And then doing some really nice math here. Some stuff simplifies out pretty nicely. Nice. Yeah. Yeah, that's cool. That's cool. It's 1/2. Yeah, sick. Okay, cool. Here, let me see if equity's here. I would love to do part C and part D, but let's save that maybe for another time. Noise. Your questions are trilogies, or they're like multi-part, which is fun. I had a lot of fun with this one. I remembered a lot of like cinch and cosh stuff. That was pretty cool. All the kids are probably like, what the fuck is this? It's just like, you thought sine was bad. You thought arc sine was bad. Get ready for hyperbolic sine. All right, cool. Equity, what's up? Let's do your question, dude. I'm here for it. Good question. Noise. I appreciate it. Here, Equity, let's get Equity up to this. Thank you, Ramit, for helping out with that one. That was a workout, man.
Yeah. That 2 that we missed though, that
Oh, I know, dude. I was like, no. I was like, where's this 2 coming from?
yeah.
Equity, how's it going, brother?
It's great. How are you
Good.
doing?
I'm doing great. Doing excellent. Excellent, man. All right, here we go. Okay, this has to do. Okay, look, these are fun. These are called transversals. Transversals. Okay, transversal just happens whenever you have 2 parallel lines. If you have a line that's crossing them, that's called a transversal. Okay. And there are a bunch of rules here about like what angles equal what angles. All right. This is geometry, I guess, right?
Yeah. It's
Okay.
like proofs.
Proofs. Okay, cool. So they say given angle 1 is equal to angle 5. Okay. They want to prove that L is parallel to N. Okay, that's cool. Well, if angle 1 equals angle 5, these are called corresponding angles, right?
Yeah.
Okay. And if the corresponding angles are equal in this type of situation, then they're parallel, right? I think that's all you have to say. Geometry's kind of weird
Really?
sometimes. Yeah, Ramit, do you have an opinion on this one? You have an opinion on geometry proofs here? I'm just like they're corresponding angles, things got to be parallel, right? Or is there a more rigorous proof to this?
Usually for like proofs, you at least have
think-
like 3 to 4 lines.
Mm-hmm.
What we're supposed to. Yeah, I think that. 4.
I like if we wanted to do the formal thing, right? We would say like measure of angle 1 is equal to 101 degrees, right? That's given.
Oh, yeah,
Right?
right. So 1 and 5 are equal. So yeah, I think that's pretty much it. Yeah.
Right? And then I say that what do I this is where like geometry is so weird sometimes because I'm like, do I have to define like what an angle is? Like
Yeah, I think the only way that I've seen is like because 1 and 4 are complementary, and then 5 and 6 are complementary, and then the whole Z thing where 6 and 4 are equal to each other. Then
Yeah.
that makes L
That-
and N parallel.
parallel. I'm trying to is there a situation that
think-
1 and 5 could be equal and they wouldn't be parallel? I don't think so.
No, because like I think because they're complementary with
Or-
4 and 6, and then they're equal, then it makes it parallel.
Right? Yeah. Okay. So, sorry. Oh, you mean supplementary, right? Not complementary?
Oh yeah, supplementary. Sorry.
Yeah.
Yeah.
Right. Yeah. 5 is supplementary to 6. 1 is supplementary to 4. 6 and 4 are equal, and then that's alternate interior angles of a transversal or parallel. That's probably the more rigorous way to do it, right?
Yeah, I think that's the name. I forgot the name. I
Yeah.
always
Yeah.
just call them like Z angles.
The Z one. Yeah. Okay. So here, so equity. What we're gonna say is that sorry, angle 6 is supplementary to angle 5. Okay, and that's by is that called like is that called collinear angles? Is that what they call that?
I think
Angle
so.
6 and 5. I'm not sure.
I forgot the name of the theorems for all of the.
Yeah, I know.
geometry.
Dude, this is why like geometry, dude, is like the ugly stepsister of math, dude. It's just like I'm just like what? It's just all this weird like shapes and stuff. I'm like, chill. Collinear angles. I
By
believe.
observation.
Yeah, I'm gonna collinear angles add up to 180 degrees. That's what I'm
Would
gonna
it
say.
be called linear pair?
Linear pair. Thank you. See, you're the one actually taking this class. I've just taught it so many times. Linear pair. Thank you. Thank you. That's what I was looking for. Thank you, Equity. Okay, so 5 and 6 are like that, and then I'm going to say that angle 4 is supplementary to angle 1. That's also a linear pair, right? Okay. Then angle 4 is equal, or whatever this, to angle 6, and that's by the oh man, what's that process? There's like if this plus this equals 180 and this plus this equals 180.
Alternate interior angles.
No, that's what I'm going to prove eventually. But it's like if I have like x plus b equals 180, and then like x plus c is equal to 180, then b is equal to c.
Is that like the transitive property? Like that states if A equals B and B equals C, then A equals C, or
Yeah, that's
if
slightly
A
different.
equals B.
Yeah, if a equals b and b equals c, a equals c, yes, that's the transitive property. I forget what the one is if like they both add up to the same thing. I think they call this like subtraction. This is called like subtraction. I think is literally what because if you subtract these two things, right, you just get that b is equal to c. But okay, maybe let's say transitive property. I kind of like that. Whatever. Actually, yeah, okay. Transitive. And then we can say that L is parallel to N by what is it? Corresponding alternate interior angles are congruent, sorry. With transversal and parallel lines. That's what I would say. That's what I would say, equity. If you wanted like the full geometric proof, I think that's what it is. You could honestly just say that they're corresponding angles. So like, if they're corresponding angles, the things have to be parallel.
Okay.
Yeah. 105. So they're saying angle 3 is something and angle 6 is this. I think it's the same thing. You say that this must be supplementary to this one, right? And then you can prove that this angle equals this angle, right? You can say that 3 plus 4 must equal 180, right? And then so 4 is equal to 75, right? And then 4 equals 6, same thing, alternate interior angles. Right?
Okay.
Okay. Prove 8 equals 2. Oh, given 8 equals 2. Okay, this is alternate exterior angles. This is just straight off the bat. That's a definition. Alternate exterior angles are also always equal. If you really wanted to do it, if your teacher's just looking for you to write more lines, you know, you can say 8 equals 6 because they're vertical angles. Right? You see how this equals this? Because they're vertical. And then you could say that 2 equals 4 because they're also vertical angles. 4 equals 6, alternate interior angles. Given 7 is supplementary to 2. Okay. Okay. So 7 equals 5. 2 equals 4. Now we get 5 must be supplementary to 4, which means that okay. 5 and 4 are supplementary to each other. What does that tell me? I don't think that's another thing. Oh, okay. Here's what we can say. Because 5 is supplementary to 4 and 3 is also supplementary to 4, then 5 is equal to 3. And then again, it's alternate interior angles. Do you see that?
Yeah.
Cool. Weird questions, but did that help you out a little bit?
Yeah.
Okay, cool.
Thank you.
You're very welcome, dude. Nice. Okay, I think that's all the screenshots. Teacup, you got your point for your stuff. Okay, awesome. Sweet. Okay, Cool. All right. Thank you everyone for coming to office hours. Had a fun session today. Learned a lot of stuff.
Nice.
Had a great time with you guys. Went a little bit over time. It's okay. User to equity. All right. It's Friday. Friday is Roblox. If anyone wants to play Roblox with us, that's the game we're gonna play for Friday. I think. Where's Minion? Minion usually plays Roblox with us. Let me post this in recess. Here we go. Roblox gamers. Time for Roblox games. You guys get to choose what Roblox games I play. But anyways, yes, thank you everyone for joining the stream. I had a great time learning with you guys, all the questions, super fun. The next stream will be on Monday, but this time we roll all the times back. So Monday will be 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. And then keep the lookout. We're gonna maybe be adding a podcast series next week, which I'm super excited to do. I've had a lot of fun with this so far, and I'm seeing the need for us to have more sessions to talk about other stuff. And if you guys have any suggestions or other things you guys want out of the stream, like please let me know. Like I stream for you guys. I don't stream for myself. I talk to myself enough in the mirror. You know, like I don't need to do it on Twitch. But yeah, okay, cool. All right, let me get this going. Manager. But yeah, if you want to stick around, we're gonna go play some Roblox. So please join in, have fun. If not, have a wonderful weekend. Hope you guys enjoy. We will see you again on Monday to go over more of your questions, and I'll see you guys then. Peace.